So final schedule. Let me rearrange windows. Just in the chat, posting on the random review. So we're up to the final presentations. We have 4 days of presentations to come. We have signups available for each day. And again, if you're going to graduate for Bhutan, we need you in the first 2 sessions. And the earlier you present, the more time you'll have. We'll be generating a minute-by-minute schedule. And let me make a note on that to follow up on that. But it'll be just a few minutes a person. And that's just enough time to look at your slide, play your demo clip, and if there's time, see a live demo. Then, as I mentioned before, once you present, we have the cutoffs for this review cycle. And then crucially, if you miss that schedule, you haven't failed, you finish when you're done. So after this review cycle, we'll then be continuing to do evaluations if there's things you haven't finished. And then if you haven't yet presented, we'll do presentations next in January at the start of the next cycle. So do get signed up to present. Then let me recap. I did this before, but let me do it again. When you present your final project, the goal is integration. So I want to see 2D and 3D, additive and subtractive, design and produce electronics, embed, interface, and program microcontrollers, and then integrate all of these. And integrate means more than a tangle of wires. It means you design how everything fits together and package it. And I'm going to show you lots of examples of those. And then you need to answer, what does your project do? Who's done what before you? What did you design? What are the materials and components? Where did they come from? How much do they cost? What processes were used? What did you need to answer? What did work? What didn't work? I want you to answer, how do you evaluate it? How do you decide if your project is successful or not? And then what does it imply for the future? They can be separate or joint, but they need to be separately demonstratable. And so that's the final project. Then this is a very important instruction that it's easy to get wrong. We're going to make a site that looks like this of each of you has a slide and a video. And for each presentation session, we'll have a detailed schedule that looks like these, that links to the slides and the videos. For that to work, you have to name your slide presentation.png and put it in the root of the repository. Then you have to make your video. We wanted an MP4 encoded for HTML5. And it should be about a minute long, and that should be about 10 megabytes. And that goes in the root of the directory. And then Ricardo's noting the root in mkdocs is within mkdocs. It's the root of the content tree. So over the next week, Julian will be setting up the generator of the presentation pages. Let's see, Julian will be setting up the generator of the presentations like this. And we'll need everybody to test to make sure your slides and videos appear on that page before the presentation schedule. And so we'll be circulating an issue on that, and you'll hear more about that. These instructions sound straightforward, but just before classes, we typically have to chase some students that have the thing misnamed, put in the wrong place. We want to get that up early. So I'm going to start by talking about project management. I did this at the first class. I'll do it again at the last class. And then with the rest of the class, I'm going to take you on a grand tour of final projects to inspire you and to challenge you. And finish with some thoughts for the future. And yeah, Ulu is noting, you won't be able to push your content just before class. The pipeline takes a while to run. You need to get all of this done well before the presentation. So first, Murphy's Law. You may have heard of Murphy's Law, which is what can go wrong will go wrong. So Murphy's Law would seem to say what can go will go wrong, and so your final project may fail because of Murphy's Law. But Murphy's Law is misunderstood. He worked at a place that tests missiles, and when he formulated Murphy's Law, it wasn't an excuse. It wasn't what can go will go wrong, therefore it's not your fault if something goes wrong. Murphy's Law was a challenge. It was to say what can go will go wrong, therefore you need to anticipate what can go wrong and design around it. So it's not an excuse, it's a challenge for you to anticipate failure. So wires could get pulled out of connectors, so you need to strain relieve the connectors. Your software could grow to run out of memory, so you need to manage the growth of the software. The power transistors could overheat, so you need to add heat sinks and thermal faults. You need to think about what can fail and design around the failure in advance, is the real meaning of Murphy's Law. Triage is you're going to run out of time to finish what you want to do. And so in medicine, when there's, say, a train crash and the first responders come, if somebody can walk away, they're probably fine and you can fix them later. If somebody's near death, you may not be able to help them. Triage is where you find the people you can save. And so for your project, you need to find the parts of your project you can save. Give up on the ones that won't live. Don't worry about the ones that are easy, and find the critical ones. And in particular, for most of you, you'll need to reduce the scope and focus. So I'm just looking for integration, and typically that means you need to reduce the scope of the big vision just to get parts going. We saw a few really good examples today of documentation during development. So we saw sites where the content was filled in as people were working, and just before you present, there's nothing left to do because you've documented as you've worked. We also saw a lot of sites that had almost nothing, where people have a big job to come to get their documentation. So even if you haven't been doing it, from today forward, just every day as part of your workday, build documentation. Make that part of your habit. I've said all these before, but I'm going to say them again because they're so important. Demand versus supply side time is here we are today. Here's where you present in time. If you do a task, then a task, then a task, you risk going beyond the presentation. Instead, what you need to do is take the time we have and divide it up. And so make a schedule of every day and what has to happen each day. And you'll be surprised how well you can work to the schedule. Now, that means each day you have to do triage, but define the time per task, not the task per time, and work back from the calendar. And so make a schedule between now and finishing, and then to a great extent, you can work on it. Then, and I've said this many times, but again, I'm repeating it because it's so important now. Spirals is, instead of going from start to finish on the project, you do a small project, but a complete one, and then you add features, but each time around you have something you can test. So we saw the, in Rwanda, the station to give feedback. And so a first spiral could be all mechanical, just the physical interface, but no function. Then the next spiral would be a button, and the button can react. You can measure the button, but it doesn't do anything. Next would be the button to the display. Next would be a few buttons, but each time around the spiral, you have something you can test. And that's really important so that you don't start at the beginning, get at the end, and it fails, but you keep having incremental stages you can test for the project. Then we saw this in the nice Gantt chart before the break. If you do task, 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 if one task fails, it can block all the tasks that are after it. Instead, you want to think about tasks takes different amount of time, but you want to work the tasks in parallel rather than in series. So if any one task runs into trouble, it doesn't block the other tasks that you're working, and you can do triage around that. So keep all the tasks in your project working. Don't do them one at a time so that a failed task can block all the other tasks. Then system integration means not just you've made all the parts, but you need to design how they come together. So let's see. Many years ago, a colleague, Robert Moog, invented Moog synthesizer. And the company eventually, this was the first electronic music, legendary, but the company eventually failed. And one of the reasons he blamed it on was the way they had designed the circuits with the chips in them. They could come loose when they were shipping them, and they had a lot of trouble with unreliability. And so system integration means not just what are all the parts, but actually designing how they fit together, how they get mounted, how they get connected. So you need CAD for the complete system, and you need to design how all the parts fit together. So it's not just a tangle of boards and wires, but it's something that'll keep working after the class. And then I'll add a link here. I was mentioning before, the idea of 80-20 it's a name for extrusions, but more importantly, it's a principle that the version of it for today is if you think about the if this is all the different tasks you need to do, you're making great progress, everything's coming along, and then you have the last 20%, but the last 20% ends up taking most of the time. And so what you think of as you've designed everything, you've tested everything, you've made all the parts, all you need to do is put it together. You'll then find once you put it all together, it doesn't work. And then you need to do debugging and triage to figure out. So don't underestimate the time to take a whole bunch of things that work separately and fit them together into something that works together. The last little part takes much more time than all of the things that get there. And related to that is just modularity. That design your project with modular systems so you can debug them separately and put them together. And then finally, at the very end, and I'm going to show you an example, is the finished quality. That starting from the same tools you're using, you can make something that looks clumsy and messy and clearly made in a fab lab. And you can make something beautiful using the very same tools, but just by thinking about steps, feeds, and speeds. And so something I want to look for is the finished quality. And in the end, not looking like a fab class project, but just a beautiful finished artifact. So all of these sound obvious, but they're not. And all of them are skills you can master and are essential for project management and are really crucial for you to be able to finish. Between now and finishing, it's very easy to run out of time. The class isn't how to almost make almost anything. I want to see you finish something that works, not fail at something more ambitious that doesn't work. The main goal is integration. Okay, so think about all of these very explicitly as skills to master. So with that, now I'm going to take you on a tour. So for the rest of class, I'm going to browse a range of types of projects to show what they look like. So this one, I really like this one for finishing. So this is a motion system. The videos show this is what we want in the videos. They take you on a tour of the processes. And then I just love where the project finished, which is it's just this magic skateboard park. And there's no visible means of anything. All of that's integrated in this beautiful skateboard park. Yeah, see, Haifi is asking timing. Yeah, the project presentations next Wednesday, Friday, Monday, Wednesday are all 9 o'clock Boston time. And we'll be posting a minute-by-minute schedule, so you know exactly when you present. But this is a great example of a project that's just featureless, that in the end, there's no visible means of technology. It's just this beautifully finished skateboard park. Let's see. This was Nadia, the designer, who I showed multiple times, who did online design. And then this is exactly what she wanted to do. She wanted to do visualization, but now this is physical visualization. So as you build the puzzle, it visualizes the puzzle construction. So she demonstrates the project, and then notice how nicely this is an example of what I'm describing is just system integration, packaging, how she's designed how everything fits together. So she demonstrates what the project does. Then she's taking us on a tour of how she made it. And then a nice integration of processes. Let's see. This was one of the best projects for finish quality. So he's passionate car designer. And so this was an environment for automobile design. And so it gives you data from the cars. And in particular, more than I think any project, he really worked on just surface finish, painting, preparation. And so he'll show all of the work he did starting from the Fab Lab to make these beautiful cars. So printing, sanding, painting. And then just these beautiful cars that don't look like DIY Fab Lab, just beautifully finished.
Are you a parent who's sick of pushing a stroller around? It can get pretty tiring pretty quickly, don't you think? So many things in our life have become hands-free. Turn off all the lights. Turn on the thermostat. So why are we still using both hands to push strollers around? Enter the Strobot, the stroller robot. From its beautiful curved design, all natural wood, and elegant simplicity, it truly is the stroller of the future. Let's go ahead and admire this for just a second. No handles, you ask? That's exactly the point. Strobot was designed to stroll straight ahead of you. And yes, it can absolutely steer and turn corners with a simple wave. How cool is that? It's so simple and so easy to operate. I don't know why these things don't exist. Just throw your beautiful little one in there and let the Strobot do all the work. And if you stray too far, it'll bring your baby right to you. Notice how free my hands are. I can do anything. Answer the phone, play with my kid, anything. So won't you just give it up, 'cause you don't understand. Beg it up, but you don't understand.
So I show this for a couple of reasons. One is it's a nice example of integration and packaging. Second, he had no background in any of this. He was terrified at the beginning of class. And then third is your videos can tell stories. Your videos can be funny. Take us on a little trip in your little video clip. This is a nice example of that. Some of these I've shown before, but I'm going to show now at this point in the cycle. So I'd say this project, more than any project, integrated everything. So this was a dollhouse, and she wanted to show every single thing we covered in some part of the dollhouse. And so she did a great job of, let's see, here she talks about the system integration of just that little peak is what I'm talking about, routing how everything comes together. But each part of the house used a different part of the class. So you ring the doorbell and you appear inside, and then can fill the swimming pool. And so that was maybe the best example of using all of the skills. Then you've gotten to know Adrian from the Saturday sessions. This is Adrian's project. And this was another nice example of finish. So here you see what just looks like this beautiful train set. And so start by machining. And by the way, Adrian's day job has been real trains for people not familiar. Then again, nice example of just, this is designing system integration and packaging. This sounds like a meme in the chat. Who is Adrian? And then now molding, casting, composites. And then this is now where it crosses the threshold, where then he's doing the materials and finally ends with this beautiful train set. Hefe is asking, some video show the project, some show the steps. Is there any hard rules? There isn't a hard rule, meaning the goal of the video, and you know what, let me make a note to explain this. Add video. The demo video, we want to see what the project does, and then we want to see what's inside, how it does what it does, and then we want to know what enabled that. So it has to show the functionality, and then it has to show how it works, what's inside and what makes it work. Beyond that, it's up to you how you tell the story, that there isn't a rigid format. The typical format is you first show it, then you show the steps of making it, and then you demonstrate what it does at the end. But it's up to you how you tell the story. But we want to see what it does, and then we want to see what makes it work, what's inside, how it works. Let's see. This was impressive in Shanghai for the final performance. This was a high-speed Rubik's Cube solver. Let's see, let's go back to the beginning.
Solving in 3, 2, 1.
Oh wait, here, let me blow this up and do it again.
Solving in 3, 2, 1.
So that one's not elegantly finished. It's amazing for what it does. Then this is on a different scale. This is one at Vegan Ashram dealing with the problem of cow feed and all of the effort to do it. And so this is a really large scale project, making plasma cutting to make a large scale cow feed shredder. So we'll go on. And so here she is demonstrating the cow feed shredder. So impressive, large scale project. Let's see, just for time. this was somebody who works in the theater, and A Fountain as Despair was from, I believe it's from a Shakespeare play. And we never before and never since have had a Fountain of Despair project. What always amazes me is just every year how every project can be different. But again, this was a good example of taking all of the processes, integrating them, and then once it's done, so web interface to it. Once it's done, again, there's no visible technology. It's just this really striking Fountain of Despair. Let's see. This project I particularly like. This was a smart interactive lamp. So it adjusts the lighting by opening and closing. What she did that was particularly notable is watch what she's doing here. She didn't just make the project, she made the packaging. And so there's her final project as a product ready to ship. And so that was a real extra credit thing where she designed not just the project, but the presentation and the packaging to distribute the project. And here again, let's see, I'm gonna, if I go back and stop, this is what I mean by system integration. You'll see she didn't just design all the parts, but she's designed how all the parts come together into a system. Just that image is a good example of what I mean when I stress system integration. Let's see, this was a nice one for magic. This made a fire by ultrasonically making with an ultrasonic humidifier and then lighting it to make flame to create this magical effect. Let's see, I think Miriam's on. Miriam has the prize for the best icons in the class, but she did a great job of making this helmet, and her video does a good job of storytelling. So this really interesting object that doesn't look like just it came out of a 3D printer, but also really nice storytelling in the video. Miriam, any comments about making this?
I kind of wish I was still using it, but I have since learned how to do better electronics. And so I'm working on making a version, I don't know, 2.3 or something of it.
Good. And
Still in
I'll talk about that at the end of class. But yeah, this is a nice example of just in our little video taking us on a trip. And actually, Adrian, since you're on, any comments about making your project?
No, I think you need to talk about the problem. If you want to solve your final project, want to solve the problem, first solve the problem, then the process of the fabrication, and finally the solution.
Good. Then let's see. This is one of my favorite projects for let's see, and some of these I'm going right to the video, some I'm going to the site. This is a good example of just what a final project site looks like, of navigating through all the steps, and we get to the end, and so nice example of system integration. Sorry, is Arnar there? Can you unmute?
Yeah, he's here.
Hey.
Yeah.
I
So
can't.
can you hear me?
Now, yeah.
Now, yeah.
Yeah, so I love this project for it solves the crucial problem of the cereal getting soggy. And the video again does a really nice job of showing system integration, packaging, finishing it. Yeah, any things you can share about to students doing their projects about your experience doing yours?
At least back then, I had to use the Tiny, so it didn't have a lot of memory. And if I were to do it right now, I've been playing around with the Arduino. I bet I would be able to use the accelerometer, and it was basically a last-minute project. Like I deviated like the last 2 weeks into this project, so it was a really much of a crunch. So I was able to do it, but it was not what I wanted to do.
But I love what came out from it, and it is a good example of ideally each week builds and the whole cycle builds to the final project. But there are many examples like this where stuff goes wrong, and at the very end you pivot and you pull together a project, and where it ended up is very impressive. I enjoy showing this project to people. It's a great example.
Thank you.
Okay, good to happen to see you in the lab. This project so what he's doing is he's taking the noise our 3D printers make and he's turning it into a musical instrument. The project was simply making a control device and just taking a little, here, let's go back on. It was just a little passing thought of being interested in the sounds of our machines. And so he made a controller that sends G codes to the printer that lets you control it to make music. Let's see, So the projects can be silly, they can be practical. This was maybe one of the most interesting art projects. This project was a sous vide cooker where you cook things at low temperature. And the low temperature came from Bitcoin mining. So it was using a Bitcoin mining rig to do sous vide cooking. And it was kind of a performance piece to connect those two attributes together. This might be my favorite project for Magic. So so this has coils to do magnetic levitation, and then is sending data to make a cloud that tells you the weather. And so when you're done, there's just a floating cloud telling you the weather. And this might be the best project for Magic, where there's just no visible means of anything, just a floating cloud. Then this, on the other hand, this might be the largest project. This is a human-sized hamster wheel. And so large format machining, instrumenting. And then smartphone interface. And we have this human-sized hamster wheel. So that might be, let's see, the largest one. Let me see if I can remember which the smallest one was. Let's see. Let me, as I go by, we've had a number of guitars. This was one of the nicest guitars. Ricardo, no, that was an individual final project, not a group project. He had people helping him put it together, but that was an individual project. So let's get to, so he wanted to make a guitar that glowed. So again, system integration, the technology is invisible, beautiful integration. Let's see, this one I've shown before. This is another one that was one of the best ones for Magic. This is a off-center weight. With a Bluetooth interface. And so the off-center weight spins. Yeah, and so when you're done, it's just this black sphere that's autonomous. You know, almost science fiction. Judy's asking a good question about the special mention, largest, smallest, magical. You know, there are examples I've shown of the most practical project. There's also examples of the silliest project. Let's see, I'll find for you the smallest. See, this was a fun version of a, let's see, where's his video? Sorry, I'm missing his video. Ricardo has a great video of his lightsaber, but I'm missing the video on the page. But let's see, that was a fun example of storytelling in the video. This one, oh, now this is a great example. When I yell it, not yell, but when I tell you move it out of YouTube, this is a great example. This video wasn't in the repo, it's in YouTube. And this is what happens to videos out of the repo. They just break over time. I don't know if she has a video in here. But this project I really liked. Some of the projects I've shown you are really heroic. They're really ambitious. This one is a simple moisture sensor, but really nicely done. Just beautiful attention to the materials to make this thing that you're happy to have with your plants. Of not, you know, one of the banes of the final projects is laser cut acrylic with finger joints to make a square box, as opposed to really designing interesting packaging. And so this was the beautiful design of the packaging of the sensor. This one, yeah, among other things, I like his site. He says he's never been prouder than anything. He designed this watch, and it tells time by lighting up the letters on the screen. And we saw a project that's a human-sized hamster wheel. Here, this whole project is just about 1 inch big. But he's done a really beautiful job of the packaging, the integration of the electronics, and the materials, fitting everything in that case. So your whole final project can fit in the palm of your hand. And this is one of the nice examples of that. There's a few examples of that. This was a very impressive project. This was a robotic leaf collector. And yeah, again, here's why the videos can't be in YouTube. These are more examples of those breaking. Let's see, now I showed his video at the very first class. Let's see, this is YouTube still working, but I showed this at the introductory class. Now we can see it again, because this is your journey. He wants food. In CAD week, he can make a simple CAD design. Laser cutting, he can make a small model. Large format machining, a big model. Around here, he's designing electronics and controls. And so this is the Aquaduino to power it. And this is one of my favorite videos, because he did this through the whole cycle. And at this point, he's now eating his first lettuce. And this grew into the Aqua Pioneers project. Let's see, this one I liked. Let's see where the final video on is. This one is a poetry machine that, okay, yeah, more again, YouTube, which is why we don't want that. So in practical versus silly versus art, I'm not even sure where this ends up, but it's a driven mechanism for poetry. I showed these before in applications implications. Danielle did maybe among the best jobs so far in making a complete drone from scratch. This one was a modular project. So I talked about the Moog synthesizer. This was like a Moog synthesizer, but each module was a separate function, and then you could assemble many modules together to make a synthesizer. So a big project made out of many small modules. This was one of the best projects for power electronics. This was a little cart that could go alarmingly fast. This was at MIT, and it was so fast that the campus security had to stop using it because they were worried we were going to drive it out through the window in the building. And so he did a really good job of integrating the power electronics for that one. Good. Okay, this is here. I wanted to show this one. Jonathan's project was simply a smart dice cube. And so in the end, let's see the best image. The whole project, again, was about 1 inch big and fits in the palm of your hand. And this project shows all of the skills. It shows everything I want to see, and it's just a dice cube. So Sean did the marble track in the laser cutting week, and this was one of the most successful projects in integrating skills. He made connected robotic chess sets, and so he did molding and casting to design molds that then let him cast the chess pieces to make these beautiful chess sets. Then he did the sensing to sense the pieces on the board. And then he did the actuation with an array of actuators under the board. And so when you're done, the chess sets communicate between the boards to move the pieces. And I showed this in the first class. This was one of the first final projects ever, and now I'll show it again at the last class.
Hi, I'm Kelly, and this is my screen body. Do you ever find yourself in a situation where you really have to scream, but you can't because you're at work, or you're in a classroom, or you're watching your children, or you're in any number of situations where it's just not perfect? Well, Screen Body is a portable space for screaming. When a user screams into Screen Body, their scream is silenced, but it is also recorded for later release, where, when, and how the user chooses. The main body of Screen Body is.
So Tahifi's question, in this case, she tells the story, demos it, and now she goes on and explains how it's constructed and what's inside it. So that's a tour through to Judy's comment, some of the biggest projects, some of the smallest ones, some of the most silly ones, some of the most serious ones, some of the most interesting, best finished ones. that's what the final project looks like, to inspire and challenge you. And so as you finish, remember, I'm just looking for integration. This isn't your life's work. It doesn't have to be heroic. I just want to, I want to see that you can integrate all of our skills into a final project. And so remember that you're going to get your slide and video posted shortly. The site will be up for final projects, and we need to make sure before you present, yours are linked to be able to present. Sorry, let's go back one. Think very explicitly about all of these lessons, to use time well, to document as you go, spiral development, all of those things to finish. And we hope to get as many of you through in time to present on this schedule. Now, once again, if you don't succeed at doing that, you haven't failed, you're just continuing. And so if you miss this presentation, if you present, but you're missing some of the weekly assignments, you can catch up on those after the presentations. If you're not ready to present, the next presentation cycle will be, oh, let's see. Adrian is noting the page is up. Okay, so this will be coming up and it'll be scraping your sites. And again, we'll be posting as that gets filled in. If you're ready to present, but all the weekly assignments aren't done, you can keep working on that. If you aren't ready to present, we do that twice a year. We'll do it at the beginning of the next cycle in January. So you're done when you're done. But having said that, we do want to get as many of you through as possible. And so it's fine to reduce scope as long as you show the range of function. It's not your life's work. It's just a masterpiece, an exercise to integrate the skills. And so we hope to get as many of you through as possible in this cycle as possible. If you're not sure, try, make an attempt to finish. We'll do our best to help get you through. Now, finally, stepping back, once this is done, you're done with the Fab Academy, you get the diploma, the sites stay active, and we keep the list of graduates. And so many people keep working on their sites, which is absolutely fine. And then there's a number of things that can follow. So in Academy, there's a growing group of classes, and there's some new classes coming. And one of the things we've been developing are a more advanced thesis program to keep working. And so you'll be hearing more about that. And then one of the things I mentioned in these, so the startup recitation, the video is linked, did a really good job of showing early stage startups, late stage startups. And then I introduced a distributed incubator. And so this is the beginning of a growing group of very successful entrepreneurs who are going to become mentors. And so rather than you going to the incubator, we're going to bring the incubator to you, where you can help develop ideas locally with global mentoring. And so we're still working out how that's going to work, but that'll be a coming attraction, and you'll hear more about that in Bhutan. We do want to get as many of you as possible there. This is my favorite annual event, and it's the most diverse gathering I know, but it's sort of the same person in many different packages, and it's in a very special part of the world. So that'll be coming this summer. And then finally, looking ahead, let me remind you what we just did. Each week, we covered a skill. So there were 3 things. The first thing is, what is that? So molding and casting, you now know what it is. And when you would use molding and casting instead of 3D printing. Then the second thing is we did examples. And so you learned enough to do a molding and casting example. And then the third thing we did is pointers. So you know where to learn more about molding and casting. So you're not a master of any of these, but you've been introduced to each of them, and then you've integrated them in the final project. A way to think about this is there's a nonlinear ball of knowledge, and we unrolled it through a linear chain to go in through your eyes and ears, and then it's reconstructing in your mind in this nonlinear ball of knowledge. And so we're just finishing that now. But the key thing to take away is this class begins when it ends. That over the next few years, you'll unpack what we did, and it'll make more sense, and you'll keep learning in each of these areas. I enjoy teaching it every year because I take it every year. Every year, I learn a third new things in the class through teaching it. So don't feel like it's done. You should feel like it's just beginning. You'll keep learning and mastering all the things we raced through. And as you've seen, many of the students become gurus in the network, and many of you will become gurus and mentors in the future, like many of the people who have helped you as you help pass this on to future generations. And so with that, that finishes the last class. So now look for updates from us with detailed scheduling on the project presentations. And I wish all of you, let's see, Adrian, you're still doing Saturday sessions, I assume, correct?
Yes, Neil.
Okay. Let's see, Jason, yeah, Saturday will continue. Jason, sitting in on classes, attending the classes, we limit to students just for interactivity, but all of the content, we post the videos right after and share that. But we try to manage the interactive participation to the students participating, just to manage a size for interactivity. So you can breathe a sigh of relief at getting this far. You can, I guess, breathe a sigh of diving into the final push. Use time well. Ideally, and for most of you, what comes is challenging, but really rewarding as you find you can integrate all of this. And all of the projects I showed you look impressive, but they were you. They were people like you pulling everything together in these final projects. So I'm eager to see over the next 4 sessions what you can create. Good luck. And I'll see you next Wednesday for the beginning of the presentations. Bye-bye.
Thank you, Neil.
Bye.
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 Thanks.
Hasta pronto.
Good luck, everyone.
Ciao.
Bye-bye. Thank you.
Bye.
See you.
And I see Yuichi's cat is wishing everybody.
Hi, Yuichi.
Bye-bye.
Let me know what you need from Bhutan, Neil.
We'll do. I'll send you a note.